Alrighty. It gives me great pleasure to welcome a new friend onto the stage, Adrian Peret, who is the Chief Architect Cloud at Nokia. Adrian tells me he lives in a forest. We met last night, and his cities are too noisy and forests are awesome, and the children can run around freely and have the fun that they have and we had as kids as well, which we don't much have anymore. Adrian, welcome to Athens. It's a pleasure to welcome you here, and I look forward to hearing your talk.
Thank you very much. Well, I think I need some device like this. So, okay, it seems that it's my turn to entertain you for next 30 minutes or so, right? So, my name is Adrian Peret, and I will talk about Edge Cloud. I was asked by the organizer that I should say a few words about me. So, here I am. That's me. So, the guy in the red suit, usually, that's me. I love cave diving, and I'm doing it a lot, as much as I can, not as much as I would like to do it. So when I'm not doing this one, which this have nothing to do with the talk that I have today, basically I started as an engineer, as a tech support in Nokia, something like 19 years ago, when I moved to Finland. I'm originally from Romania. And then I changed my role and I moved to Saudi Arabia. Of course, if you like cold stuff, then of course you move somewhere in the middle of the desert to figure out the opposite side. But the idea was to learn more about sitting basically with a customer, right, in a first line and second line support. Then I changed my role again to hosting service line. Basically it was, how should I call it, was the beginning of, or a try from the telecommunication to provide telecommunication services as a service, okay? Then I also changed again, and I moved in the managed services to learn more about operations. And then I moved in the connectivity side with remote access solutions for Nokia. And now here I am, fancy title, whatever, Chief Architect Cloud. But what I'm trying to say is that I'm just trying to apply and learn all the time new things. So I'm not really happy only stuck in one place. But again, you might see I'm stuck in one place for a long time because I don't believe that you can master something in a short period of time, no matter what. So, and also because I'm learning slow and forgetting fast, it doesn't really help much. So I stuck with one thing for a long time till it comes inside my head. I will still, this is kind of not so interesting, but I still need to provide you some, let's talk about some big numbers, big economical numbers, right? So the digital transformation is not something new. It is ongoing now for, 5-6 years in different industries. But mainly we have the, let's say, digital, digitalized companies, right? The digital industries, which they were the ones which actually started doing this, and they've been very successful. Let's give some example. Music industry, right? So CDs and stuff, then now it's MP3s, streaming, so you can get stuff digitally. Books, the same. You have a physical book, now it's not physical, you can get it on. But, so basically 70% of actually investment in digital transformation is done by this kind of ICT industries, right? But if we look out, basically also they are benefiting out of it. What means is that you can see that it is the productivity actually is 4 times higher in these digital industries than actually in these other industries. And when I'm saying other industries, I'm talking about physical industries. And the physical industries, even they look like, when I say physical industries, means factories, right, which have a lot of assets, factory robots, all kind of things which are physical, and there is not much, you cannot really digitize a drilling machine, right? So that drilling machine needs to drill a hole, and that's not going to be really possible to do it digitally. You cannot simulate that you drill a hole. Actually, you can, but it's not going to be any hole in your wall. Okay, and what is happening that this physical industries actually takes out 70% of the overall global GDP. And that means it's a very big one. And actually it's hiring 75% of the workforce globally. And you can see they are only 30% investing in this industry. And why this actually happened? Because the initial step was basically to do a transformation of physical to digital, and that was the initial part when all the digital companies were very easy to benefit out of it, right? So you take whatever you have, you digitize it, and you can leverage that one. But now the whole point about this, the Industry 4.0, how we call it, it's actually the possibility to actually control the physical world using digital. And that is all about in the Industry 4.0. So now we should have the capabilities that whatever we have in a factory or whatever we try to do, and then we have a mean to control it digitally. Because of course we cannot replace it. That's, as I explained, not that easy. Maybe somewhere, but not yet. What this has changed? So what is changed actually across these industries? The IoT application, which currently I guess all of you or some of you are playing home, maybe like, I don't know, temperature, you are based on your thermal sensor, you are fixing your air conditioning, and all that stuff. It's very fancy and nice, cool stuff, but they are really simple, so they don't have really big demand, right? So if you don't find, if your temperature, you know, it's 2 minutes late or even half hour late displayed on your graph, I don't think you are really much bothered. Or your air conditioning starts 30 seconds later than it's supposed to start. I don't think you are that annoyed, right? So there was some example before with the Facebook that it went down, and well, some people were bothered, but not really that many. Now in this new industry, in the Industry 4.0, there are some business critical environments. When you are, for example, a lot of applications, they are mission critical. So when you are controlling, for example, a robot, or you are controlling some machinery, you cannot really have a delay, because if there is any kind of delay, that machinery may do some very stupid things. So, and also you need to have a reliable low latency and bandwidth, which is always there, available for all this machinery to actually work. So if you want to operate this machinery from the distance, in the end, you need somehow to deal with all these new things. So what is here is telling basically the light blue is showing that this is how all started with the digital world, with very limited IoT part, and now we are actually moving towards the other areas like 360 videos, virtual reality, virtual radio access network, vehicles, and then controlling systems like robots. And you can see they demand very high bandwidth, very low latency. And that is a challenge. That is a challenge because, because actually there are some laws of physics which I will talk about. So let's see. This is a graph showing what is the latency requirements, right? In different, let's say, in different services, right? So we have for reference the green one, which is basically a sprinter. It is able to react after the pistol, or how it's called, it's shot. Then it can react in 120 milliseconds to start running. Vestibulocular reflex, which is very fancy name. I'm not a doctor, but I can tell you that actually I'm doing it right now. What that means is that when I'm watching, sorry, I'm watching you here in the first row, but it's not intentional. Basically, I'm moving my head in this direction, and my eyes, my brain will figure it out in under 7 milliseconds that my eyes should actually move opposite direction. Otherwise, you will be blurred in my face. So that's a very important part, and it's kind of, we do it without even realizing, but it's kind of very tight values there. So as a reference. Now, you have the maximum application delay for processing, which is in dark blue. It is showing for different services how much time can be spent in the application to be processed, and then there is how much time actually it's allowed in the networking to happen. And that starts to be very tricky. And why? Because we have laws of physics with some light propagation in the fiber. That's telling us that, okay, so roughly, this is not exact numbers, but roughly, if I want to have 1 millisecond round trip time latency, that means cannot be more further than 100 kilometers away, right? And that's not much to be done unless some, I don't know, new Einsteins figure it out that, okay, to speed up the speed of light, which, I don't know, sounds kind of stupid, but that's the only way to overcome. So we are basically constrained by something which not yet figure out how to overcome. And that means, well, not figure out how to accelerate the speed of light, but we figure it out how to overcome. What means is that we need to bring, to obtain these latencies, we need to bring the computing power closer to the source. And that's what I'm about to talk about edge. So, of course, some of the things can be fitted in, let's say, a central data center, whatever you consider a central. I will go later on in more details. But mainly, a lot of services can be achieved only if those services are actually running in an edge data center. Why this happened? So, of course, with 5G, there is some triggers, right? Critical machine communication, massive machine communication, extreme mobile broadband, and 5G. That brings there is a heterogeneity of use cases, and that means, okay, latency need to go down, throughput goes up. So, okay, somehow we need to fix it. Centralized data center, they've been built by the laws of economics, not the laws of physics. So there is a problem there. But then the edge data center, actually now they are driven by the laws of physics. So what is the best solution? Well, actually, the theory is that you should centralize as much as you can and distribute only what is a must, because it's quite costly, but it's unavoidable. The triggers for the edge, there are many. So let's start with the fixed access network. So there is a way to now, if you have an edge cloud, you are actually able to control, to deploy there the controlling part of the fixed network as well, so you can reuse already existing transport. Public-private cloud ecosystem, the innovation itself, virtualized and distributed IP edge, latency, bandwidth, and security critical uses, IoT and MEC it's multi-access edge computing. There are a lot of acronyms here, so you can ask later on. I don't know all of them, so don't worry. Okay, RAN cloudification, this is radio access network cloudification evolution to 5G. And now let's talk, what does it mean, when we say an edge data center, what do we mean with it? Because it's, again, a term which is very much used all over the place. We divided the data centers in two big groups. They are central data centers, which we mean could be regional or central. But in the telecommunication world, usually nobody have only one data center somewhere central, because that's not a very wise way to do it, because if all goes sideways, then you have no communication. Usually there are at least three. Every country, I don't know about Greece, and the Greece operator, I don't know now the details, but in Finland, for example, there are three all the time, and a certain distance, physical distance on it, and they consider all these three regional as central. So again, there is a very blurred line. Is it a central or is it regional? So those are kind of, depends who you ask and who you talk. Now when it comes to the edge data centers, there are two. First of all, we call far edge data center the last hop before the remote radio head. If you are wondering what is the remote radio head, is that, well, more or less ugly or not, antenna which sits on all kind of poles, and you know that your phone is actually running, connecting through it. And the last hop before that we consider a far edge. And usually in a 5G communication, that's the distributed unit which sits, which is the one which have a very demanding latency requirement. The aggregated edge, we call it an edge which is usually the controlling unit of the radio sits, and it sits further. Now it starts let's say, the very scary part, right? You can see the numbers of sites on far edge. That means hundreds and thousands of edge sites. And I can tell you that's a very conservative number. Publicly, it's available, for example, China Mobile. They are estimated the need for edge data center to fulfill the latency requirements to 100,000. Okay, so 100,000 small edge data centers spread around the country, that's a lot of things. Of course, it's not really a data center as such, but it's actually a cloud, right? It's a one individual cloud, which is like in 100,000 number. Other operators are let's say in the US, you get my more conservative numbers with, well, 14,000, between 10,000 and 14,000 sites. So I'm saying this is very conservative number there. In other countries, in Europe, there are like 100, 120. Again, depends on the particular use case that we are talking. So the key here is that the numbers it's huge. So there are some problems which comes with it. And I like also cars, right? So you will figure out soon. So when cars started, right, let's look at it. The upper part, it's about applications, right? Cloud native or whatever you want to call them. In the bottom side, we talk about infrastructure, OpenStack, Kubernetes, whatever. So when the cars came out, right, the roads were like kind of adapting to be suitable for those cars, right? Then much better cars came around and roads improved as well, right? Then we got better and better cars and better roads. And future, who knows what will come and what kind of roads comes out. But what it means is that you cannot run a cloud-native telco application on a traditional cloud infrastructure. The infrastructure must evolve in the same time as the application evolves. So it's kind of very, because I heard a lot of time that, yeah, right, it's like just IT infrastructure, why you cannot run a VNF there? Well, not yet, but it will come a time when, yes, you can. Actually, we can now, but I'm just saying that in the end, the open community need also to evolve and contribute to development to allow actually such an application to run in a cloud. So what are the challenges in edge data centers? Well, remote sites will limit space and power. So you don't have, when you are in a top of the building where your antennas is, you don't have that unlimited power and unlimited space there. So you have a very limited, which sometimes is traduced in really limited power, right? For example, up to 2.4 kilowatts per site. So what you can do with 2.4 kilowatts, you want to build a cloud which consumes 2.4 kilowatts only, because putting more power there, it's not an option. You have data center hardware. Actually, if you take the current IT hardware, whatever you try to fit it, unless you use a very big hammer, you cannot fit it in the telco sites because they have a different dimension, which I will cover later on. Cloud infrastructure actually is not, it's not suitable for small deployments. What I mean, think about it. You have a remote site where you have one server, and now I want to run an OpenStack cloud in that one server. So currently, yes, we can do it. As well, I'm from Nokia, and yes, we can do it because we have no choice. We need to make it happening, but it's not easy to do it, right? It's not available really easy. Or you want to have it not necessarily one server. If you want to have ability, you need to say, okay, I want to run it on 3 servers, right? Because of the voting. So I need to have a minimal 3, but it's fine. You need to be able to do that. You need to manage thousands of small clouds, which I told you. When we say manage them, that's a very tricky thing, because you need to imagine that when you distribute the clouds in a telco way, that means that will be physically located in a different, very strange places. And any visit there, that have a very big financial impact. So it's not like, oh yeah, this cable wasn't that right, I go now and fix it in the data center, or I call somebody to do it. You can't, because it might be in a, I don't know, maybe 100-meter tall pole somewhere, which somebody need to climb on it, and just to do that job, and need the correct weather, the correct wind speed, and so on, just to go and fix a cable which you didn't put it right. So there are some additional challenges which require all this edge cloud, how we call it, to be very, very compact and very easy to be deployed and managed and operated. And then, of course, there is a potential lock-in in proprietary solution, and that we don't want. Even as we are a producer of telecommunication equipment, we really don't like to have proprietary solutions because it's not helping us, it's not helping anybody. Now I will talk in more details, right? So let's talk about the hardware. I'm talking about that, okay, you cannot fit the hardware. What does it mean? What do we need to do about it? So give an example. I don't know if you're familiar with the data centers. In the telco side, you have a maximum depth of 600 millimeter. And in the back of that location, it is a wall. So you have no cooling possible on the back. You have no access on the back, and it's maximum 600 millimeter depth. So currently, you cannot take any IT hardware and fit it there, unless, again, you have a very big hammer to put it in. Then using any kind of tooling, it's not a good idea, again, because this equipment can sit in a very strange location. So you want to do anything which you do with it without any tools, right? Power consumption, we said it's very limited, so you need to do something with 2.4 kilowatts. And what you can do with that? Well, you can do actually a lot. So we managed to, in 2.4 kilowatts, to put 5 single socket servers, and each of them with 20 cores. And then there is a lot of computing power actually there. So yes, it is possible, and this kind of design allows us actually to build such a site. And you can see here that's an example. Basically, in the bottom side, you have it's called AirScale base station. Forget the name. It's just that it's a Nokia product, but forget it. So basically, it's just showing you that, look, this is the typical telco side size. And you can see on top the actual hardware, which can actually fit there. And we didn't like to keep anything closed, so actually we open source the design of the hardware, and it's part of the OCP now. So it's all open, so anybody can build this kind of equipment based on design which we did. So we really want to be open. We open source even the hardware design. So it's available there. It was, I think, 1 week or 2 weeks ago when was the OCP summit in US, it was actually also accepted there. So we work on it for something like, I don't know, 2 years or so. Now when it comes to infrastructure, to the cloud infrastructure, we talk here a lot about OpenStack, Kubernetes, and so on. So telecommunication have some very stringent needs there. Yes, I know the application is the one, all the redundancy need to be in the application. Yes, it's great, but some things are regulated by the specifications mentioned before, and then there is not much turnaround. When you have a total budget of declaring a call dropped of 1 second, and you are, as an example, you are a pacemaker crossing from current OpenStack, it's detecting the failure in about 8 seconds, well, there is a little bit of a problem. So you won't like your phone to be dropped, right? Because if the failure is detected 8 seconds later and your budget was 1, so not good. So we need to do something about it. And you can see there is a requirement saying fast recovery in milliseconds, so it must be sub-second. And that is a requirement from infrastructure. And by the way, crossing and pacemaker, it's monitoring only the compute nodes, actually. And it's not the controller nodes, and compute nodes or storage nodes are just forgotten or any other thing. So it's, again, not a good idea in the telecom side. You need to be able to fit it small. I need to read from there because, well, I wear glasses, but, well, doesn't help. So I need to read it here. So I will not read it all, so don't worry. So you need to, very important thing. So small footprint, which it's very important, and then, which was talked here, APIs are extremely important to operate it. Means deployment, operation, lifecycle management, absolutely everything must be able to be done via APIs. Why? Because these are remote sites where you don't want to go, plus there are so many. So I don't think anybody is interested to, I don't know, if you have 100 clouds and you need to change the password and it takes you a minute, you have 100 minutes just to change this password. I don't think it would be the best job in the world. So GUI is out of question. So everything must be controlled via APIs. Hybrid, which is, again, very important stuff. We talk about containers, we talk about all the future, but the reality it's a little bit different, means that the VMs will be for a while here to stay. And what that means, we need an infrastructure which is able to deploy on it virtual machines, but also containers in the same one. and to be under the same deployer and under the same management. And that's one of the requirements. Of course, need to be scalable. So, right, so once you deployed 3 servers as a minimum high availability solution, you must be able to scale from there up to whatever your capability, your site actually is. Because in some cases, it's not such as, I give an extreme examples when you have a very limited power, but in some cases, it could be also few racks. So it could be also up to 8 racks or 10 racks, one location. So it's not necessarily always this tiny little thing. And now comes the management. So how we manage all this mess? There is some needs, right? So we have hardware. Before it was very easy. I have a cloud infrastructure, VMware or OpenStack, and yeah, just make my servers ready and I'm coming to put it up. Well, it's not the case here. In the telco, it's not possible in that way. You need to be able to automatize the whole chain. Means I need to be able to automatize the hardware initial deployment and able to do lifecycle management on it remotely, and as well after that to automatize the deployment of the stack which I'm deciding to put on top. So in the end, I have a package which is actually ready to accept an application on top. Now a few examples, right? Because we talk about edge cloud, and what are we talking about? So what is helping this edge? So it's helping, for example, in predictive and improved maintenance with augmented reality, right? So it can show you directly, meanwhile wearing all kind of devices on your some kind of goggles, it can show you what you need to do next, right? What is your step? What screw you need to untie? What bolt you need to do without now studying manual or something. So this is one use case that is helping in this case. Then we had video analytics for smart manufacturing. Actually, you can find in the internet, there was a Nokia and Telia. So Telia is the operator in Finland. They did they used 5G in our own factory in Oulu, and they used it for quality control, right? So the machinery goes extremely fast with all the pieces there, and there was a camera, and it was monitoring the devices, then sending to an edge cloud for processing and immediately sending back the answer so that if there was a broken piece, it could be immediately removed from there. You cannot just send it to some centralized data center and 2 seconds later to get the answer back to kick that piece out, because that piece is already used in somewhere it's assembled already. So this is another use case of it. Localized content distribution with highest bandwidth. So this is the case of edge video orchestration, when you have an event where you generate a lot of data, a lot of video, which is consumed locally as well. So you don't need to send it anywhere else. It's consumed locally during the event, so there is no point to take transport and use bandwidth for moving things around, which you will not later use. Video analytics for public safety. Well, that unfortunate guy in the right side, the movement was analyzed, and it was seen that, well, the guy jumped the fence, and I hope he was caught. Okay, or maybe he was late to the office, I don't know. Okay, then there is a bag there detected, and all of this can be done in real time and also in a privacy, right? And vehicle-to-X communication. So the best example is that if the vehicles communicate to each other, right? If the car in front brakes, you need to tell to the car in the back that it brakes, so they brake together, right? Now, if there is a delay in the first car telling to the second car when to brake, well, you can imagine what happened. Is all this communication need to go somewhere like 1,000 kilometers away. And now about edge. There are a huge list of edge cloud initiatives. You might think that, well, it's edge, yes, and what's that? Well, actually, there are, in my taste, with small letters like in insurance companies, I'm not talking in the company name, there are too many, right? But this is always the way, like the open community starts. There is a huge bunch of initiative, and then after a while they will settle, and some will have priorities or not. You can see in the left side, actually, it's about publicly available edge, let's say edge initiative from various carriers. You can have AT&T, China Mobile, China Unicom, and also from some analysts. And then in the right side, different initiatives, which actually Nokia is member of many of them, because we really believe in this openness. And one of the latest one, which most probably you hear of, is this Acraino, which actually we are trying to put and co-create together with AT&T so that we will actually create a proper stack which can be used for the edge. What are the takeaways? So edge DCs to provide low latency and high throughput. Not much to be done, laws of physics. Converged access, so the access will converge because of the edge, and that means will allow to anybody in any location to have the same services, right? Automation. I should have put them in a very big letters, because actually without automation nothing can happen, because this kind of distribution, it does not make sense economically if it's not extreme automated. And well, you can run, but you can't hide from it. So the edge cloud is here now, so not much to be done about. Yep, thank you very much.
Thank you very much, Adrian. All right, let's take some questions for Adrian before we move to our last talk for the day.
Yes, so very simple. You just put the application on the edge. I don't need to read the question, I think you can read it. So the whole key point is that you need to locate the application closer to your consumer. And that's the only way that you ensure this low latency. And now the key part with the edge is that the problem with the edge is that there are no two edges the same. What means is that every edge location will have its own particular services. If you have an edge location in a factory, we'll have different services, different applications running there, for example, controlling robots, right? But in the same edge, if you have it in a city, which will contribute, for example, to this car communication, then they will have different set of applications. But in the end, the infrastructure must be the same. Oh, one question. Excellent. Thank you. I can go now.
All right. Do you have any more from the audience? Because we have a little bit of time. If not, we can allow Adrian to take it easy for the rest of the day.
Yes. Thank you very much.
Again, thank you so much, Adrian.
Bye.
Thank you. Fantastic.